Hello students, welcome to my channel Concept of Maths. Today we are going to discuss class 12th maths inverse trigonometrical function and problem related to the identities of inverse trigonometrical function. Clear? Today we will discuss some questions. Simplify tan inverse a cos x minus b sin x upon b cos x plus a sin x. Okay, so we have already discussed that if we have a given tan inverse, we have to convert this whole as a the form of tan. क्लियर? कोशिश कीजिए कि ये tan में हो जाए, इसको tan में कन्वर्ट करने की हम लोग यहाँ पे कोशिश करेंगे. So what we can do, we can divide this. Also one more important thing we have given, it is a upon b. So try to change this up also in form in terms of a upon b. Clear? So what we are doing, we are dividing this by b cos x because sin x upon cos x is 10. So we have given 10 inverse a cos x minus b sin x upon b cos x plus a sin x. Clear? Okay. So what we are doing, dividing numerator and denominator by b cos x. Clear? So divide it. So we get tan inverse a cos x upon b cos x minus b sin x upon b cos x upon b cos x upon b cos x plus a sin x upon b cos x. Clear? Okay, so we can cancel out this cos x, b to b cancel out, b cos x to cancel out. Okay, so now what we get, tan inverse a upon b minus tan x upon what we are getting here, 1 plus a upon b tan x. Clear? So we can compare this by an identity as, we can write it as tan inverse a upon b minus tan inverse tan x. Clear? So what we are recall the property tan inverse a minus tan inverse b is equal to tan inverse a minus b upon 1 plus ab. Clear? Okay, further we can write it as tan inverse a upon b minus, so it is only x. Clear? So in that case a upon b tan x is greater than equal to minus 1. Clear? So this is our simplification. So we can enclose that inside a bracket. This is our answer. Clear? Yes. Another question. Question number 8. Prove that cos inverse 4 upon 5 plus cos inverse 12 upon 13 is equal to cos inverse 33 upon 65. Clear? Now we have to prove that. But the problem is that we don't have an identity for the cos inverse x plus cos inverse y is equal to cos inverse y. Clear? So to remove this problem, we have to write an identity. So identity 1 is that cos inverse, you have to recall that a upon b is equal to tan inverse under root b square minus a square upon a. Clear? And the second identity for sine inverse a upon b, we can write it as tan inverse a upon under root b square minus a square. Clear? You have to recall these two identities, then you can solve the problem. Clear? Now come back to the problem. First of all, we have to convert this a upon b in form of tan inverse. Clear? So first, what? 4 upon 5 we have to convert. Cos inverse 4 upon 5 is equal to tan inverse under root a upon b. So in this case, what is a? A is 4 and 5. So 5 whole square minus 4 whole square upon a means 4. So cos inverse 4 upon 5 is equal to tan inverse under root 25 minus 16, so 9 upon the whole upon 4. Clear? So we have converted that cos inverse 4 upon 5 is equal to tan inverse 3 upon 4. Clear? Okay. Simply we can convert the second also. Second, cos inverse 4 upon 5, 13 upon 12 upon 13 is equal to tan inverse under root. So 13 whole square minus 12 whole square upon what we have? A. So a is what? We have 12. So tan inverse 169 minus 144, 144, and upon, we can write it as tan inverse upon 12. So 13, we can write it as 25 upon 12. So root 25 upon 12, and tan inverse, we can write it as 5 upon 12. Clear? Now we get cos inverse 4 upon 5 is equal to tan this, and cos inverse 12 upon 13 is equal to tan inverse 5 upon 12. Now applying the identity of cos tan inverse, and we know that this identity, tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Clear? So using that identity, we have both of things. tan inverse cos inverse 4 upon 5 की जगह पे हम लोगों को क्या मिला है? 3 upon 4. So 3 upon 4 tan inverse plus tan inverse y. तो y 12 upon 13 की जगह पे हमको 5 upon 12. So 5 upon 12. Clear? So we can write it as tan inverse x plus y. X plus y means 3 upon 4 plus 5 upon 12 upon 1 minus 3 upon 4 into 5 upon 12. Clear? So tan inverse, so LCM we can take 12 4 to 40, we will take 48. Clear? So we can write it as 9, first 4 we divide by 48, so we have now 4 12 3 जा 36 प्लस 12 से डिवाइड कीजिए आप उसको 12 4 4 5 जा 20 अपॉन, सो 148 minus 15 upon 48. Clear? So 48 to 48 cancel out. You can write it as 10 inverse. Now we have 56 upon 33. Clear? Okay. So again, it is in terms of 10 inverse. We have to convert that into cos inverse. Again we write it as convert 10 inverse in terms of cos inverse now. So we can write it as 10 inverse a upon b is equal to cos inverse b upon under root a square plus b square. Clear? So finally we can write it as, the answer is cos inverse b 33 upon under root, we have 33 whole square plus 65 whole square, so we get cos inverse 33 upon 4225, and that is 65. So we get what? Finally cos inverse 33 upon 65. That is our answer. We move to the next question now. Now in this question we have to solve 10 inverse 1 minus x 1 plus x upon 1 plus x is equal to 1 upon 2 10 inverse x with x is greater than equal to 0. क्लियर? तो इसमें हमें क्या करना है, वैल्यू फाइंड आउट करनी है. क्लियर? ओके, नाउ सॉल्यूशन. कैन वी राइट फर्स्ट ऑफ ऑल 10 इनवर्स 1 minus x 1 upon x is equal to 1 upon 2 10 inverse. क्लियर? क्या 1 को हम लोग 10 पाई बाई 4 लिख सकते हैं? देखिए 10 इनवर्स, इसे हम लोग लिख सकते हैं 10 पाई बाई 4 बिकॉज 10 पाई बाई 4 इज 1 माइनस एक्स अपॉन 1 plus, so x into 1 1, so we can write 10 pi by 4 into x. Clear? Is equal to 1 upon 2 10 inverse x. It is as it is. So 10 inverse, okay, we can write it as 10 pi by 4 minus 10x, 10 inverse pi by 4 minus 10x, 10 inverse x is equal to 1 upon 2 10 inverse x. Clear? Can we write it as 10 pi by 4 plus this is 10 pi by 4 and 10x. Clear? We are applying a property of 10 inverse a minus b, so that is 10a minus b. Clear? प्रॉपर्टी को हम लोग लिख लेते हैं यहाँ पे. देखिए प्रॉपर्टी होती है हमारी 10 इनवर्स x माइनस 10 इनवर्स y इज इक्वल टू 10 इनवर्स x माइनस y 1 प्लस एक्स वाई. ठीक है, अब देखिए यहाँ पे x की प्लेस पे हम लोगों ने क्या लिया है, यहाँ पे 10 पाई बाई 4 है और y के प्लेस पे कितना हमारे पास x है, ठीक है। तो ये है x माइनस वाई अपॉन 1 प्लस एक्स वाई। तो हम लोग इसको ऐसे लिख सकते हैं, ठीक है। आगे चलते हैं। नाउ सॉल्व दिस। tan इनवर्स tan पाई बाई 4, क्लियर। और tan इनवर्स की यहाँ पे मल्टीप्लाई करेंगे तो कितना आ गया, माइनस tan इनवर्स x इज इक्वल टू 1/2 tan inverse x, clear. So tan inverse tan pi by 4, so we can write it as directly pi by 4 is equal to, this is minus, it can be subtracted in another side, so we will write 1/2 tan inverse x plus tan inverse x, ठीक है, क्लियर है। देखिए, so tan pi by 4 is equal to, so we can solve this, we will get 3/2 tan inverse x, कैसे, 1/2 plus 1 is equal to 3/2, ठीक है। ओके, नाउ tan inverse can be written as tan inverse x is equal to, cross multiply, pi by 4 into 2/3, clear. Okay, further we can write it as, we can solve 2 to the 4 and tan inverse x is equal to pi by 6, clear, and x is equal to 10 pi by 6. So x is equal to, we have to find the value of this √3 means cos 30, and we know that cos 30 is 1/√2, 1/√3. So 10, it is 1/√3, clear. So you can solve this kind of question, clear. We can again, I am explaining it again, so that tan inverse minus 1 minus x upon 1 plus x, this is given to us. So you have to find the value of solve when it is written solve. तो आपको क्या करना है, आपको x की वैल्यू फाइंड करनी है. So when we are going to solve, so we can first of all take a trick over there. So 1 can be written as tan pi by 4 minus x, so we will write it as, so convert to making this such as that we can make identity like that, in IDF identity. हमें इन्वर्स ट्रिग्नोमेट्रिकल आइडेंटिटी बनानी थी, इसलिए हम लोगों ने थोड़ा सा यहाँ पे अरेंजमेंट किया. देन आफ्टर वी विल गेट पाई 4 इज इक्वल टू 1/2 tan इनवर्स, ये शिफ्ट करने के बाद वी गेट दिस, एंड फाइनली वी गेट द आंसर इज, क्लियर.